Hi, welcome back. Today we're even going to do more fun stuff. I hope you really enjoyed that algebra on the last section and that you got some experience using your thing. Looks like either I'm out of focus or this is out of focus, hopefully. This is not me, my computer there. Anyhow, remember last time we developed the difference quotient. DQ got hungry, still hungry. And we said that this distance right here, I'm going to draw this with a pencil maybe. Let me see if I can find a pencil. Got a pencil. Okay. And ruler. And we said that this right here was our line kind of, and we called this a secant line, remember? Now, what we're going to try to do is draw the secant line, kind of make it into a tangent line. And the way we're going to do that is we're going to make this distance here, h, smaller so that it gets closer and closer to x. Let's make this a little bit smaller here. You see, it's getting closer to being a secant, so on. So finally, when we get down to about here, might not be the best, it becomes what we call a tangent line. So this becomes a tangent line. And this no longer becomes our difference quotient. What we're going to do is we're going to take the limit of this function, the limit of our difference quotient as x approaches 0. As this distance here becomes so small that it actually becomes just a flat out 0. Not x, sorry, h. I say h becomes a 0. And this distance becomes nothing. And once it becomes nothing, the difference between these gets so small, it approaches 0. We didn't say it equals 0, but it approaches 0. All intents, we could say it equals 0. Once that happens, then we're going to change this from slope. This will actually become our slope, but we're going to designate it with a new name, and we're going to call it the derivative of the function of x, the derivative of x. So we can show that a couple of different ways. We can write this as, sometimes this is called f prime of x, or f of x. Sometimes we read it that way. The derivative of x, f at x. We can also call it the derivative of y with respect to the derivative of x. Or we could call it y prime. Sometimes we just write it like that. All these ways are different ways of writing it. When I was in school taking calculus for the first time and just being completely buffaloed, we used to write it like this, with a big old fancy D. And I believe we put a little y up here and a fancy x down here. Well, I spent the whole course pretty much trying to make a fancy D or something like that. We did in the book, and I never knew what it really stood for. But now we just write it very simple. F prime x, y prime. This is out. This is in. Most of the time we just write y prime. Sometimes we're going to write dy over dx when we're doing a certain kind of derivative. This looks like it's fading in and out. Maybe that's better. Okay. So now we're going to write this as in different forms. So you might say written this way, or this way. This way we're written for when we do a certain kind of problem. And sometimes when we do integration, we need to write it in that form. Okay, so what this is this was the rate of change. Now this is the instantaneous rate of change. This is finding out exactly what the slope is at this particular point. And that's what we're doing here. So let's try a problem here. This one says, let's write down the 3 steps that you're going to do. Okay, number 1, you're going to write this difference quotient down, and you're going to try to find the difference quotient. Find difference quotient. We'll put DQ. Then you're going to simplify the DQ. This is where you're going to use your algebra. And then you're finally going to take the limit of h as it approaches 0. So there's 3 things you got to do. So let's start out with a basic one. I think we did this last time. Function of x equals x squared. Okay, so we're going to find the difference quotient. First of all, we're going to put in f of x plus h. This would be x plus h squared minus x squared minus the original problem over h. Then we're going to use our algebra to simplify that, right? And this became x squared plus 2xh plus h squared. I hope you're getting better at that formula, minus x squared over h. And we saw that these canceled out. And then we factored an h out of there and got 2x plus h over h, factored out this h. And then we simplified that down to 2x plus h. Okay, so that was our difference quotient. That's what it's equal. Now, what we're going to do at this point is we're going to take the limit as h approaches 0 of this function. So what that's basically saying here is we're going to let h equal 0. And that's going to give us 2x. And this now is going to become, this is our slope, but we're going to call it, this is a slope when at that point, it's not a number, you see, it's a formula. And so we're going to designate it as a derivative, and we're going to put that f prime. So we know we took the derivative. This was the original problem. And now this is the derivative of that original problem, 2x. So what does that mean? Let me show you something on the next page. What I did is I took the liberty to graph this. This is y equals x squared. I make a table of values, and I graph those tables of values. -2 was 4, and -1, and then I expanded them a little bit. You can see every time I put a number in here, like 3, I just square it. Okay, so here was our original problem, and here's our derivative, right? So at -3, the slope of this graph is constantly changing. So at -3, when we're here at -3, here's -3, the slope is -6. It actually has a number value because we put the -3 into the first derivative. And that gives us -6, and that's the slope at that point. If it was 4 right here, the slope is pretty steep, it's 8. So at 1, I used 1 here. I put in 1, and the slope is 2. 1 times 2 is 2. So the slope is 2. And let's take a look at it. At 1, I'm saying that the slope at this point, 1 is 2. That means I'm going to go up 2, and that's our tangent line to the curve. That's this line right here. That's the tangent line tangent line, and that's m equals 2. See, we're going up 2 units and over 1. And that's why we're saying the slope at this point is 2. Okay? So that's pretty much the way it's done. Okay? So here's your steps. Remember, you're going to find the difference quotient. You're going to, which is this, you're going to simplify the difference quotient, and then you're going to write the derivative. You're going to take the limit, and that'll give you the derivative. And those are your 3 steps. And now you found the first derivative of the function. So let's try another problem here. Let's go through and see if we can do another one. Let's do this. Jump down a few. All right, let's do this one right here. I could do a bunch of them, but let's try this one right here. Let's try example 3. Here's a very simple one. F of x equals 3x minus 4. And we want to find f prime x. In other words, we want to find the first derivative, and then we want to find f prime 2. Okay, so let's see if we can find the first derivative. We're going to take the limit as h approaches 0. I'm going to write it like that, of the function of x, which is going to be f of x plus h minus f of x over h. So this is going to be 3 times x plus h minus 4, because we got to put that in, minus the original problem, 3x minus 4, so we need a parentheses, all over h. So if you're having a little trouble on the first one, maybe that's what you weren't doing. So let's simplify this. This will be 3x plus 3h minus 4 minus 3x plus 4 over h. Now, all the terms that don't have h's in them should cancel. So this 3x cancels out the negative 3x. This negative 4h, negative 4 should cancel out a pot. That would have an h there. Positive 4, there we go. So this should be 3h over h, which simplifies to just h. Okay, so function prime x is h. Did we get it right? I hope so. Oh no, function prime x is 3. What am I? Sorry. Now it said evaluate f prime at 2. F prime at 2 is going to be just this number because there's nothing to substitute in. There is no x left in the problem, so it's got to be 3. Sorry. So that's what we're talking about. Sorry. This should have been a 3. What am I thinking? I'm kind of thinking ahead to another problem when I should be. Okay, I'm going to do one more problem. Let's try this one. This one we did last time too. F of x equals 1 over x. Let's find f of x plus h first. Let's find f of x plus h minus f of x over h. Let's take the limit as h approaches 0. So this is going to be 1 over x plus h minus 1 x, the original problem, divided by h. And we said crisscross applesauce, x minus x plus h over x plus h times x divided by h over 1 times h. So that simplified to x minus h over x times x plus h. I just leave it that way, times 1 over h. These canceled, and this gave us negative 1 over x times x plus h. Now we're going to let h equal 0. We're going to have h approach 0. So when h approaches 0, this becomes a 0, and I get negative 1 over x squared. Because this is x plus 0. It's not 0, it's just x plus 0. And that would be our first derivative. Okay, or you could put it at prime x, like that. So we have calculated this out, and we got our answer. Now, the next thing they want us to do is evaluate this one for a function of negative 2. Negative 2, just 2. So that's negative 1 over 2 squared, or negative 1 over 4. Okay, the last thing we wanted to do, I'm going to get another piece of paper here. The last thing they want us to do on this problem all right, here we go. The last thing, they want us to write an equation. Write an equation for this thing. Holy cow. Equation of the tangent line. Tangente line. Okay, how are we going to do that? At f prime 2. Okay, well, if we're going to do that, we got to figure out, first of all, what's the slope of this? You know, to write in a tangent line, it's going to fall in the form y equals mx plus b. What the heck is the slope? Well, the slope is right here. When we put a 2 into our first derivative, we developed the slope. This negative 1/4 is our slope. This is the slope at that point. At 2, if they wanted it at 3, we would have put 3 into our first derivative, and that would give us our slope. So to find the slope, you substitute into the first derivative. So now we know that m is negative 1/4. We know x is 2. We need a value for y. What the heck is y? When we're looking for y, we always go to the very first problem. Y is going to be, to find y, we're going to go to the original problem, f of x, which was 1 over x. So if we put a 2 in there, y is 1/2. So now we have y. So this was our value of x. We substituted into the original problem, and that will give us our value of y. And then we substitute this 2 into our first derivative, and that gives us the value of our slope. So now, I'm going to use, sometimes maybe you had some teachers that wrote the y equals mx plus b problem, and they wrote it down twice. This is a formula that will give you the slope without knowing the y-intercept. Y minus y1 equals m times x minus x1. This is called the point slope formula. It's a little bit faster. So y minus y sub 1, this is going to be our y sub 1, 1/2, equals m negative 1/2 because we're going to write this in general terms, x minus our x of 1. X of 1 is 2. So let's see what we get. We get y minus 1/2 equals negative 1/2 x plus 1/2 of 2 is 1. Okay, we're going to bring over the half, which is 1/2. So our formula should be, our equation should be y equals our slope was not 1/2, our slope was 1/4. Excuse me. We have it right here, 1/4. Where did I get the 1/2? I guess I was looking at this half too much. This was 1/4. So this is 1/4 x minus or plus, not 1/4, but plus 2/4. We'll just keep it 2/4. We bring over the 1/2, that would be 1/2. So this would be a negative 1/4 x plus 1. I'm sorry I messed up so much on that. Yeah, our tangent right here, our slope was 1/4, not 1/2. Okay. Let me do one more. I kind of got cut off and I feel bad about it. And let's just grab one here. Let's say we had this equation. Y equals x squared plus x. Or function of x equals. Okay, and we are going to write the equation. And we want to do it at a certain point. Let's do it at when the derivative is at 2. Do the same thing. Okay, so let's step number 1. Let's find the difference quotient. F of x plus h is going to be x plus h squared minus x plus h. We're going to take the limit of h approaching 0 of x plus h function of x plus h minus function of x over h equals. So this is going to be x squared plus h, x plus h squared, minus x plus h plus h, x plus h minus the original problem, which is x squared plus x. There we go, over h. Because this is x squared plus h plus x plus h squared plus x plus h. Anyhow, this is x squared 2xh plus h squared plus x plus h minus x squared minus x all over h. We're going to take the limit as h approaches 0. So let's see if some terms cancel out. They should. X squared cancels out x squared plus x cancels out minus x. So we're going to factor out an h, 2x plus h plus 1 over h. If I factor out the h. And the h is canceled. Now we're going to take the limit as h approaches 0. And this h right here is becoming 0. So now our first derivative of this function is 2x plus 1. Okay, so we got our first derivative. Now we're going to take the equation of this. Here was the original problem. Here's our first derivative. You can see it's pretty time consuming, huh? Now we're going to try to find the equation of tangent line equation at function prime is 2. We could have used any. I just made that up, 2. So how are we going to do this? Number one, okay, we know x is 2. Got to find y. Put this 2 back into the original problem. 2 in here would be 2 squared, which is 4, plus 2 is 6, which gives me 6. 2 squared is 4, plus 2 is 6. So now we know y. Now we want to find our slope, m. So we're going to put this 2 into our first derivative, and that would be 2 times 2 is 4, plus 1 is 5. Now we can put it on our formula. Y minus y sub 1 is m times x minus x of 1. So let's substitute them all in. Y minus y sub 1, 6. That's y sub 1. M, 5. X minus x of 1, 2. Y minus 6 equals 5x minus 10. Bring our 6 over. 5x minus 4. And that's the equation of the tangent line to this function of x at 2. Just as easy as stacking BBs on your hand. So, sheet of paper and lots of writing there. Okay, have fun, enjoy. Not all the problems you have to find a tangent line. It's just sometimes kind of fun to do. All right.